Welcome to straightfromthegeek.com. Today we are going to do something very different. The audience for this video will most likely be very technical, probably other software engineers. But if you are curious because you've heard the term reverse engineering and you'd like to know what that means, why you would do it, and how it's done, we're going to go through almost all of it. I'm going to try to keep the contents of the video relevant to non-technical people. Software engineers will be able to just jam through this stuff, but I want people to understand generally what this is and why you would do it. The work that I'm going to show today was done by me and my ridiculously talented brother-in-law, Dustin Norman. Dustin and I actually met a long time ago while we were both working at a company where we really were reverse engineering almost every day. That was on Windows, but the techniques are absolutely still applicable to OS X. Before we jump in, I want to make something very clear. If you follow anything that I do in this video and your machine melts, if your operating system crashes, if you lose every single bit of data on your hard drive, or if Apple's attorneys come after you and take away your firstborn or something, that's totally on you. This is totally just for explanation. I'm showing you how this stuff works. You cannot hold me responsible for anything. All right. With that said, before we jump into the methodology that we use to reverse engineer software, it's important to understand why you do it in the first place. And for me, there are generally two main reasons that I do it. One is understanding. So I download a new app either from the Mac App Store, the internet, or the iOS App Store, and a piece of software does something that I think is cool, and I want to understand how they did it, how the software engineers wrote their code and how they solved their problem. By using reverse engineering techniques, you can get a really good sense of how something is done, even when the software engineers themselves took steps to make that very difficult for someone else to find out. If you think about it, some company comes up with some amazing algorithm to solve some problem. They don't want to make it easy for me just to open up their application and figure out how they did it. But the way software works is that if it can run on your system, you can see how it works. You just have to know how to do it. The second reason I do any type of reverse engineering is I want to be able to change the behavior of the system or a piece of software. And in this specific case, we're going to change the behavior of voice recognition on OS X to do something that Apple doesn't want to be done. It wants voice recognition to work a specific way, and that specific way causes me a little bit of grief, and we'll go into why. But by reverse engineering, I can not only understand how voice recognition on OS X works, I can do things to modify the behavior of voice recognition without actually having to have access to the source code of the application itself or OS X. So understanding and the ability to change behavior are two very important keys to reverse engineering. So let's jump in and describe why we're doing reverse engineering in this case in the first place. My mom has Meniere's disease, and one of the side effects is that it is almost impossible for her and I to speak on the telephone together. She simply cannot hear me. She has a TDD telephone, which converts my speech into text, but the lag is horrible. It works maybe 20-30% of the time. So what my mom and I do is this. I screen share with her on her computer and my computer so she can see my screen. I have my headphones on so I can hear her when she's speaking. She mutes her side of the conversation because she can't hear me through the computer either. But what she can do is read my screen. So what I do is I use the dictation feature built into OS X to speak to my mom, and then she can read it. Hi, Mom, comma, how are you feeling today? Question mark. This is a great way for my mom and I to communicate. The really cool thing is that dictation in OS X, especially in Mavericks, OS 10.9, is really, really powerful. You can do cool things like 1, 2, 3 plus 4, 5, 6 equals sign 5, 7, 9. That's pretty cool. And it's really useful. So I can talk to my mom. She can read what I'm saying almost in real time. It's just a really good solution for us. She has friends who do the same thing. So this is a pretty important way to be able to speak to someone who can't hear you. So what is the problem? The problem is in OS 10.9 Mavericks, Apple changed the way this works. To improve voice recognition rates, what Apple now does, and which they didn't do in previous versions of OS X, is they automatically mute any sound that's being generated by your computer during dictation. So what we'll do is we'll come over here, I'll start a song, which is kind of mimicking my mom talking, and then I start dictation. Oh, crap. Mom, I can't hear you because OS X just muted my sound. Oh, there it is. So what this means is my mom and I can't talk in real time to each other as we used to be able to do. Again, I have headphones on, so I hear her, but my microphone does not. There is absolutely no reason for Apple to mute the sound on my computer at this time. And again, it breaks the workflow that we use to communicate to each other. So what I did, and what you're supposed to do, is you go to bugreport.apple.com and you file what is called a radar, and all that is, it's a report that either you found a bug or something in Apple land isn't working the way you think it should. And this is what I did back in August of 2013. And to date, not one person has even replied to the bug report. So I'm pretty confident Apple is not working on solving this problem for me. That's, again, not very surprising. But if I want it to work the way it used to, it's on me to make that happen. Apple is not going to do it for me. And this is where reverse engineering comes back into play. So what we're going to do now is start to figure out how we can get dictation to work the way it used to without any help from Apple. Just to make sure we're all on the same page with respect to dictation, I'm going to launch System Preferences, and down here I'm going to click Dictation and Speech, and on the Dictation tab here I have it on, and I have used Enhanced Dictation enabled. That requires a download, but it also allows you to do dictation offline. You don't have to be connected to the internet. So to follow along with what I'm doing here, you need to have this set up like I do. If you disable enhanced dictation, what I'm going to do doesn't work. So at the end, if you want to try exactly what I'm doing, make sure you use Enhanced Dictation is enabled. Okay, so we know we want to change the way dictation works, and to do that, we have to figure out what dictation is on OS X. So let's start up Activity Monitor here. I know the feature is called dictation. If I type dictation, I don't really see anything in there. What if I leave Activity Monitor up and I start dictation? Oh, okay. So dictation, when it becomes active, is this little process right here. And what we can do is get more information about that process by using this little button here. And we can look at open files and ports. And there's a lot of information here. But the very first thing we notice is that the first thing loaded in this process was this executable right here. It's in System Library Input Methods. It's inside the dictation.im.app. And we know that that is the important part, or at least the first part of what happens when dictation is active on OS X. Let's copy all of this stuff and try to clean out some of the extraneous information so we get a better idea of what's really happening. All right, like I said, there's a lot of stuff in here. I'm going to copy it over to a text editor, and I'm going to cut out all the things that really aren't pertinent to the actual execution of dictation. Switch over, and it really comes down to the things that happen. The executable parts of dictation are in here, in these files. The thing that we're going to focus on first is this dictation IM application. And if it is created with Objective-C, that's the programming language that is primarily used for OS X and iOS applications, there is something that we can do to actually poke inside of this thing and see what the creators used to make this all happen. We use a little tool called class dump, and I'll have links in the comments. Here's a terminal window, and I'm in the directory of where dictation IM lives. So that's the executable that runs when dictation is active. So what is this thing? Dictation is a Mach-O 64-bit executable x86-64. So if you're not a software engineer, that doesn't mean a whole heck of a lot, but it tells us that it can run on OS X, and it tells us some things that we already need to know, or we do need to know about it. If you haven't looked at this stuff at this level before, if you do a cat, which is just looking at the contents of this file, this is kind of what it looks like, in string form anyway. I don't know about you, but this doesn't help me in any way, shape, or form. There actually are some strings in here that are pretty useful, but right now this doesn't help us. So we need to see this executable file in a form that does help us, and class dump is a tool that helps us here. Okay, so let's run class dump against the dictation executable and see what kind of information that gives us. Ding, ding, ding. Actually, I'm going to use two options here, and I'm going to send this to this folder in my home directory, and we'll call this dictation im.h. We're assuming it's going to look like a header file. All right, now I can open that. And what this is, to Objective-C developers, you know exactly what this is. To the people who haven't done this before or aren't familiar with Objective-C, these are what are called the classes, methods, and instance variables that make up this application. So here is something called the Dsr Application Delegate. And what does this thing do? Well, it has these methods on it. It says disabled dictation, duck audio. I wonder what that means. What are some of these other? Start a dictation session. That sounds interesting. Start listening. Start monitoring for insertion points. Whatever these are. We don't know. These are just names of methods at this point. But what we do know is this. What do we want to change about dictation? We do not want it to silence audio while dictation is active. That's our whole goal here. So if we come up to the top of the file and we search for something like silence, there is a method called silence audio, and it takes one argument, a Boolean argument. So somebody somewhere calls this method, and it's either saying silence audio true or silence audio false. That sounds pretty interesting to us. And what is the class here? We scroll up, and again, it's the application delegate. So in a minute or two, we know that dictation is made up of one of these classes, and that class has a method called silence audio. That seems really interesting because that's exactly what we're trying to make not happen. So what if we did some nasty stuff? We got inside the dictation app while it was running, and we made silence audio do nothing. So when dictation wants to silence my sound or music or whatever, I can change this to don't do anything. So it will think it's silencing the audio, but it actually doesn't. It actually won't do that. And here's the nefarious part of what we're doing. We're jumping off into something that this is a good path to follow, but we're going to find something here when we go to the next step that this is overkill. We're actually looking too deep into what is going on. If we continue down this path, I will have to write code that injects itself into the dictation IM process and then hacks around to change the way it works. And this happens all the time. If you have a plugin, even in Mail or something, this is kind of what you do. But we're going to find that going to this level is not a requirement in this case. But we are going to take that next step and then see why we don't have to go this way. Okay, that next step includes figuring out what this silence audio method actually does. Right now we just know the name of it. We can maybe guess what it does based on that name. We hope it's doing what we expect it to do, but we don't know for sure. So let's figure that out, what it actually does. And to do that, I'm going to use an awesome program called Hopper, which is a disassembler. I'm going to show you what this looks like. So remember that dictation IM thing that we've been looking at lives in system, library, input methods, inside the dictation application, contents, macOS. And here is that actual file. Remember, we looked at it, it was all this squirrely text. We have no idea what that is, but Hopper does. So let's ask Hopper to look at this file for us. And what is going to show you is assembly language, which is kind of really the lower level things that it's generated by the Objective-C compiler. And you don't need to understand this stuff. It's a little squirrely. But it's not hard either. You can really figure this stuff out pretty easily. But we want to look for silence audio. And there was that class, Dsr Application Delegate. And if we look here, yep, that's the silence audio method. Let's see what the silence audio method actually does. So here is the start of that method. And if we look around here, let's just see. It seems as though it's reading a preference. And if you're familiar with OS X, you kind of know what the preference system is. It's a way for applications to save preferences, really. Where does the window go? What color does the person like their text and everything? But look at this. It's reading a preference, and then it's looking for something called allow audio ducking. And again, if you haven't spent much time with audio stuff, ducking is kind of like muting. So this sounds pretty interesting, and it leads us away from going down that path of injecting code into dictation in IM and changing what it does in runtime, because it seems to be that there was probably a string that we can set in preference files and make the app do what we want without actually even going in and doing any of the nasty code injection. So we need to figure out what these strings are, and that's the next step. Before we move forward, I should have pointed out a little bit earlier, in case this really is your first time looking at something like reverse engineering. Reverse engineering is part science. You need to know how the system works, how the programming languages work, what executable images look like when they're on disk, assembly language, the preference system. There's tons of things to know from a technical standpoint. But the other side of it is really just experimentation and investigation. Case in point, here the system actually gives us a really good indication of what's going on without us having to do all this looking at assembly language and guessing. And I'm going to show you what I mean by that. Let's open TextEdit again and open up the console app. Let's clear this. And what I'm going to do is I'm going to temporarily enable voice recognition. And we're going to watch the console log to see what the system tells us without having to do any work at all. Okay, so I very quickly enabled voice recognition or started dictation, and then I stopped it. And what we see here are messages from the speech recognition daemon. This is the thing that's running kind of at a lower level. It's handling the requests for speech recognition. And if we look through here, there's some interesting things. We can figure out that there are sound sources. These are probably C++ classes. But where is it? Here. What is this? Audio ducking was already off, disabled. Is there more of that? Audio ducking was already off, disabled. Audio ducking is now on. So right here, it looks like this is where audio ducking or muting of whatever the computer's sound is generating, right there is when it was turned off. So we know that something down in this speech recognition daemon is at least querying or asking or reporting about the state of audio ducking. This would be a really good place to go and look to see what's going on there. This might actually help us in our search. So again, the other side of reverse engineering, it's doing this investigation, hunting around. Some of it is just luck. You stumble on a string or something that makes you go, oh, I wonder if it works like this. So this is what we're going to do moving forward. We're going to go find where that string is being displayed into the console here and hope that that information gives us more to go on moving forward. All right, let's take a look at that speech recognition daemon in Hopper. So we'll do a new, I'm going to read executable. I've already gone through the directory structure here to find out where that daemon is. I'm going to open it up, and let's look back at the console. Audio ducking is now on disabled. We're trying to find out where that string is being sent to the console or the log. So I'm going to look for strings. Audio is, oh wait, audio ducking, that's right. Right there. So in the data section here are the strings. Audio ducking is %s, %s, %s. If you're a C programmer, you know that this is a printf format string, and we can go to the cross reference where this string is used. I say go, and let's look at this code here. We are in what is probably a C++ method. Here's the class, here's the method. Set audio ducking state bool. So again, that sounds pretty in line with the kind of things we're looking at. And let's, okay, here it is, look. Audio ducking is now on disabled. Let's look back at the console. Audio ducking is now on disabled. This is where the code is generating that string, so that's pretty cool. So we know there's something to do with audio ducking for sure. If we go back and actually look at the symbols instead of strings, audio ducking. Allow audio ducking. Where is that used? Oh geez. Okay, here we are. This is exactly what's going on. We're in a C++ constructor, and you can see here that the code is actually reading a preference, and the preference is a string, and it's allow audio ducking, and then it's giving the exact preference database that it's reading from. So again, you need to know how preferences work and stuff like that on OS X, but this is what this tells me. If I set allow audio ducking in this com.apple.speech recognition core preferences database, I bet you if I set that to the Boolean on or yes or 1, that gets us farther than we were. This is telling OS X when it does this stuff, read this preference, and I'm going to trick it and make the preference be false. So it's going to ask itself, is audio ducking allowed? And instead of it working the way Apple wants it to, I'm going to make it say no. Audio ducking is not allowed. Do not do audio ducking. Do not mute the sound while speech recognition is running. Okay, let me record this piece of information that we just found. I'm going to jump back to my scratch pad, and if I was going to do this from terminal, it would be a defaults write com.apple.speech recognition core allow audio ducking bool no. So we're telling the speech recognition daemon you are not allowed to do audio ducking. So let's give that a whirl, shall we? Okay, so the step now is to check to see if this solves our problem or not. I'm going to go over to terminal. I'm going to write this into the defaults database. I'm not going to go into defaults. You can figure this out through Google. It's widely documented. So we set this to no, audio ducking no. Let's go back to text edit, pull up this. So to test it, I need to start a song and see if dictation mutes my sound when dictation becomes active. So let's see. Oh, crap. Well, that didn't work. The behavior is exactly the way it was in the beginning, which is interesting in this case because it gives me the opportunity to show you that reverse engineering isn't a, hey, look I found this thing and it's done. Right now, I think a lot of people would maybe just give up. Oh, it's not working. I don't know what's going on. This is the point where you just have to keep digging. We found something that I believe is important, but there may be something else we have to do to get the behavior that we want. We're not going to just quit. We have to keep looking. Okay, I just spent a few minutes looking at the other executable pieces that are inside of Dictation IM when it's running. If you remember, I captured the frameworks that were loaded inside of Dictation IM, so I can go through each one of these and now start looking for preference strings that kind of makes sense to me. And what I did was this guy right here, dictation services, I opened that in Hopper and I started to look for the strings that we kind of believe now kind of control the audio silencing or the audio ducking. And if we look for the string side and I say ducking, there's a string called dictation IM allow audio ducking. And the fact that it's capitalized and it looks like this, again, to me makes it look like a preference. So let's see where this is used. If I look for cross references, right here. Okay, this is exactly it. Here is that string, and we know, look, that it's looking for a preference, or it's dealing with preferences. And here is the ID that we need to set this preference. So here's the full name, and here is the string. So let's go back to my text editor and let's put that in here. So now we have two defaults settings that we need to set, or we believe we need to set to get dictation to work the way we want it. We had this one before. This one is setting on this preferences database, and we're going to say dictation allow audio ducking no. And again, it's a Boolean. So we had set the first one. Let's set this one. Okay, so now we have that one set and we have our first one set. Let's go back to text edit. Let's bring up iTunes here. And I'm going to start playing the song, and then I'm going to start dictation. If you notice, dictation is still working and the sound is not muted. So it looks as though we did exactly what we wanted to do. It took a little while. It took some knowledge of how the system works and everything, but really it comes down to these two lines. We didn't have to change any executable code. We didn't have to do any kind of nasty code injection. It really was just poking around, and it came down to finding two specific strings. Now, if I set that string to yes, it's going to be either way, but let's just do it like that and try it again. you see, it stops. It goes back to the default behavior. Forget about this. Let's go back, set it one more time to no. And now it works the way we want it to. Now again, obviously this is not, I wouldn't be playing a song loudly while dictation is active, but the fact that I have my headphones on when I'm talking to my mom, the system never hears her voice. So dictation still works great, and we get to communicate. And I didn't have to wait a year for Apple to decide or not decide if they were going to allow it to be a preference. I sincerely do hope that Apple will at some point allow this type of behavior to work, even if it's not the default behavior. I hope this gave you an idea of what reverse engineering is, how you might go about it, some of the things you have to keep in your head while you're doing it. There are a ton of really great resources on the web for learning, like x86 assembly language, how the lower level parts of OS X and Windows or any operating system works. If you have any questions, please send me email. I'm more than happy to discuss this stuff. And I just hope it helped you understand a little bit more about how software works at a lower level. All right, do something geeky today.